Welcome back. I am Largo, and today we're going to check out another video by Kurzgesagt. This one's going to be what happens if you destroy a black hole. This video was a commenter suggestion, so thank you very much for that, and keep those suggestions coming. As far as I know, black holes, I don't really know of a way to destroy them. I'm sure it's possible. I know black holes merge with each other and get larger, where one will consume the other, so I don't know if that counts as destroying a black hole or just adding the mass of one to the other. I don't know. So I'm not a theoretical physicist or a scientist, so I'm sure they've got plenty of theories out there as to how you could potentially destroy a black hole, and theories about what would potentially happen if you did that. So I'm kind of curious about it. I always love learning about the universe. I always love learning about science and how things interact with each other, nature, all that kind of stuff. So let's go ahead and learn something new, hopefully, and see what Kurzgesagt has to say.
Black holes can destroy everything, but can they be destroyed? What happens if we push physics to the absolute limit, maybe even breaking it and the universe in the process? Let's create a tiny black hole about the mass of our moon in the Kurzgesagt labs and try to rip it apart.
All right.
Experiment 1. Nuke it. Big booms break things, so to set the mood, let's explode the world's entire nuclear arsenal around our black hole. Boom. Black holes swallow whatever crosses their event.
Yeah, I don't know how effective nuking things would be, because black holes regularly consume stars, and stars are just massive, constant nuclear explosions on a scale far beyond anything humanity's ever even been able remotely to touch, even barely conceive of. So I don't know, even a tiny micro black hole, I don't know, man.
Horizon, matter and energy. And since E equals mc squared, all the energy that enters a black hole increases its mass. The mass of a black hole is proportional to its size, so as we nuke our tiny black hole, it just gets bigger and more massive. Experiment 2. Antimatter. Matter and antimatter annihilate each other. What will happen if we throw a moon's massive antimatter?
This is an interesting one. Theoretically, even a minuscule amount of antimatter, when coming into contact with matter, destroys itself. It supposedly creates a massive reaction, an explosion, and destroys both the matter and the antimatter. I don't know, man. This might be a way, because black holes are simply just matter condensed down into a single point in mass. Oh man, so I guess if you had enough antimatter, you probably could destroy a black hole with it?
At it. Unfortunately, when an object enters a black hole, the black hole will completely delete its past identity, whether it's made of matter or of antimatter.
Really?
Black holes only care about gravity, which only depends on the total mass energy of an object. And the mass of a particle is the same as its corresponding antiparticle, so throwing an anti-moon has the same effect as throwing a moon. The black hole just gets more massive.
Okay. All right. I was kind of wrong in my own theory, but like I said, I'm not a scientist, and this is pretty neat. Okay, so you can chuck antimatter into a black hole and it should still function like normal.
This deleting ability of black holes is pretty interesting. It means that despite their size and power, black holes are, in a way, similar to elementary particles. An elementary particle like an electron is an extremely simple object, fully specified by just 3 numbers, its mass, spin, and charge. And amazingly, the same is true for black holes. They have a mass, they can rotate, and carry an electric charge.
Man, it's what? See, that's one of those things that's just wild to me, and I love to learn these things. It's absolutely insane sometimes how difference in scale both has mirrors and has a lot of differences. So what I mean is, you can look at something very small, and the example they gave here is an electron. So they're comparing an electron to a black hole. A single electron is tiny. You know, it's smaller than an atom. It's part of what makes up an atom. Yet a black hole is so huge and massive and has so much mass that it's collapsed in upon itself and is a singularity. So they're like opposites, and yet they kind of mirror each other in the way they function, which I think is interesting. Now, that's not always true. Sometimes when you get down to like the subatomic level, things start to almost ignore the laws of physics and reality when you get down to a small enough scale. But there are some mirrors to these relationships between like subatomic things and things so massive and large that it's just so interesting when you're learning about the universe and how all of this kind of connects together from the smallest scale to the largest scale. There's still a link that joins them together.
Charge. Once a black hole forms, it doesn't matter if it comes from a collapsed star, an anti-star, or a banana, it will always be fully described by those three numbers, nothing else. But if a black hole is basically a weird particle, could we destroy it with an anti-black hole? Experiment 3. Anti-black hole. How exciting! A particle has the same mass as its corresponding antiparticle, but opposite charge. Since a black hole has mass and electric charge, its corresponding anti-black hole should have the same mass and opposite electric charge.
This is very interesting to me, an anti-black hole. Now, I'm wondering, is this purely speculation? Is this 100% theoretical? Or have we some kind of evidence that something like an anti-black hole can exist, or does, or would, or conceivably could exist? Man. Ooh, the old tingles on the brain. I love it.
What if we make them collide? Sadly, the charge will just add up and cancel out. So after the collision, we'll just get a new black hole twice as massive with no charge. Okay, we need to think bigger and stretch physics harder. Experiment 4. Destroy the event horizon. It's true that a black hole can carry spin and charge, but even for these crazy objects, there are limits. If the spin or the charge of a black hole becomes too large, something really weird will happen. The event horizon will dissolve. In a simplified way, we think of black holes as hiding a singularity inside, an infinitely compressed mass with such strong gravity that absolutely nothing can escape from its surroundings, not even light. This is why a black hole looks like a black sphere of nothingness. The event horizon is the outer edge of this ultimate prison. Cross it, and you'll never be able to come back.
I think kind of what they're talking about here is they're almost talking about a black hole like a balloon, right? The event horizon is that the actual skin of the balloon that kind of holds it all together. It's that line, the point of no return, essentially, where once you cross that event horizon, no form of matter, mass, light, or anything can escape it. Gravity's too strong, and once you cross that line, that event horizon, there's no coming back. But I think what they're talking about here is essentially, if you destroy the event horizon, it's kind of like destroying the latex on a balloon. That encapsulating membrane is gone, so that the air inside can just escape. That's pretty interesting. Let's see if that's what they're talking about.
But when a black hole rotates, it works a bit like a spinning washing machine. It's as if the rotation wants to repel nearby objects and push them out of the black hole, which doesn't happen because its gravity is so strong. But if the rotation gets too fast, this effect will win and the event horizon will disappear. Nearby objects won't be imprisoned forever anymore. The same thing happens with the electric charge. Make it too large, and our ironclad jail will break open. If we manage to
Okay, so that's essentially what they're saying. It's kind of like popping the membrane of a balloon. It allows what's inside to escape.
destroy the event horizon, the singularity would still be there, and objects would still naturally fall towards it. If you hit it, you would still die horribly and quickly. But the vicinity of the singularity won't be an inescapable prison anymore. You could get as close as you want and come back. This should count as destroying the black hole. Can we do it?
I kind of agree. I think it should count as destroying the black hole. While its singularity is still there, the core of it is still there. A lot of what makes a black hole, that event horizon, is gone. You know, it becomes an escapable prison as opposed to an inescapable prison. All right.
Experiment 5.
I think that counts.
Overfeeding.
Overfeeding. Okay. So I think in this experiment, they're going to try and get the black hole to collapse in on itself.
All we have to do is to overcharge or overspin the black hole. We could do this by
Or overspin it, I guess, which would cause things to radiate outwards in like an accretion disk and send matter flinging outwards.
throwing objects with a small mass and a lot of charge or angular momentum so that the charge or spin increases faster than the mass. We have to overfeed the black hole until it reaches the point where it breaks open. However, whether you can actually do this is the subject of passionate argument among physicists. Think of a charged black hole. Equal charges repel each other, and the more of the same charges you squish together, the more they push back. So let's say that we have a negatively charged black hole and we want to overfeed it with electrons, for example, whose charge is far larger than its mass. The electrons will feel an electrostatic repulsion, and the more electrons we throw, the larger the negative charge of the black hole will be and the stronger the repulsion. But once we reach the upper limit, the electrostatic repulsion will be so strong that it won't allow any more electrons to come in.
Okay, I see what they're doing. They're less overfeeding it than they are overcharging it. You know, they still have to feed it in mass, but they're trying to feed it in mass in such a way that they're feeding it more electrons than mass. So they're increasing its charge without trying to increase its mass at the same rate. Oh, that's an interesting idea. It essentially makes the black hole self-isolating, pushing material away from it rather than pulling it into it. That's interesting. Still doesn't kill it though. It cuts it off from its source, but it doesn't kill it.
At this point, the black hole will refuse to be overfed. With the spin, it's similar. Once the black hole reaches its upper limit, it won't gobble more spin. But some scientists have discovered what looks like a loophole. If an instant before the black hole reaches the limit, we throw the right amount of matter in just the right way, it looks like we could actually overfeed it. Most scientists are skeptical, but let's give it a try anyway.
Let's.
The end? Breaking physics.
All right.
There is a catch though. The event horizon of a black hole hides the singularity. So destroying the horizon would leave us with a naked singularity, one that is not hidden by an event horizon. And this poses a problem. It could mean the end of physics as we know it. There's a big dirty secret about black holes. Contrary to widespread belief, the singularity of a black hole is not really at its center. No, it's in the future of whatever crosses the horizon. Black holes warp the universe so drastically that at the event horizon, space and time switch their roles. Once you cross it, falling towards the center means going towards the future. That's why you can't escape. Stopping your fall and turning back would be just as impossible as stopping time and traveling to the past. So the singularity is actually in your future, not in front of you. And just like you can't see your own future, you won't see the singularity until you hit it. But you also can't hit something that's in your future.
I wasn't even thinking about how gravity bends space-time. Gosh, I wasn't even considering that. That's a whole new bag of cats, man. Jesus. That was not even factoring into like my mental equations about how gravity bends space-time. Oh man. That just complicated it so much more.
Future, only sort of experience it, like you'll experience your next birthday when it happens. Singularities that are in the future are not a problem because we can't see them or interact with them. But a naked singularity would be in front of us for all of us to see. What would we see? Well, the whole point is that it's impossible to know. A singularity is a region of infinite gravity, and gravity is the bending of space-time. At a singularity, the bending is so radical that the fabric of space-time is literally broken. Space and time don't exist anymore. This means that you can't predict anything.
That's also why wormholes are a possible idea when it comes to black holes. Black holes may be wormholes not only into other places, but also other times because of the way it does distort that space-time. Oh, man.
Since predicting means making a forecast about where and when something will happen. But where and when have lost their meaning. So we have an unpredictable thing with infinite gravity and therefore infinite energy. This means that anything could come out of it for no reason, from a pile of bananas to lost socks or a solar system. Predictability, causality, and physics as we know it would break down. We think that singularities should exist in nature because we can prove that under very general conditions, gravitational collapse leads to the formation of singularities. However, scientists think that nature forbids the formation of naked singularities. Something enforces the creation of an event horizon around them to prevent their insanity from infecting the rest of the universe. Without event horizons, physics may not make sense at all. So although black holes have been portrayed as the ultimate monsters of the universe, they may actually be the heroes that keep us safe from the madness of singularities. So if we do destroy the horizon, we might destroy the fundamental rules of the universe. You know what? Let's not do that. Conclude.
Even before they brought that point up, I would still posit that it's a bad idea to attempt to destroy the event horizon of a black hole. I mean, because even without thinking about all that stuff and all the wild potentials of it, just the sheer release of energy from something like that would probably destroy. Yeah, it would destroy like just everything for quite a while. We're talking like whole star systems, maybe entire galaxies, depending on the size of the black hole. Oh yeah, wild.
The safe option.
The safe option, okay.
As far as we know, there's just one safe method to destroy a black hole. Wait. All black holes emit tiny particles, a phenomenon called Hawking radiation. This process causes them to slowly lose mass until they eventually evaporate, leaving behind no horizon and no naked singularity. The time it takes for a black hole to completely evaporate depends on its mass. For our mini black hole the size of a speck of dust, it will be about 10 to the power of 44 years, 10 billion trillion times the present age of the universe. So is it possible to destroy a black hole? Yes, we just have to wait.
Alright guys, that was another video by Kurzgesagt. What happens if you destroy a black hole? Very, very, very interesting. I mean, obviously all of this is theoretical. None of this has actually been put into practice. We haven't really seen any of these phenomena happen. Short of actually having data that black holes exist, a lot, if not all of this is theory. But man, woo! These are guesses, but they're educated guesses. A lot of interesting things that they brought up, from antimatter to anti-black holes to removing the event horizon to trying to overfeed them with mass or overcharge them with electrons. A lot of crazy ideas. But that's why I love these videos so much. That's why I love the universe and learning about the universe and the possibilities of what is potentially possible out there. Man, it kind of dwarfs everything else if you just sit back and kind of like objectively look at what you're learning about. It's just like, the cosmos is insane and it dwarfs everything that we can conceive of. And there's so much more to learn. There's so much more we don't know. There's so much more we don't understand. There's a lot of stuff that we would like to theory test and try, but we don't have the technology to do it. But I think this one is very, very interesting. I would say my favorite ones in this particular video were the concepts and the idea of trying to remove the event horizon from a black hole. That to me is like a wild idea. It's almost like a black hole is like this cosmic egg and we're trying to remove the shell from that egg and we have no idea what the contents of that could contain. You know, for all we know, it could be something simple as a huge destructive reaction that destroys half the universe. Or it could completely destroy space and time and physics, at least in the surrounding area of this, you know, naked black hole. Just the ideas are wild, the concepts are insane, they're massive in scale. But that's why I love these things. I love learning about it. I love science. I love space. I always love when I learn something new or something that gets my brain to think, you know, starts dusting the cobwebs off those wheels up there. So, and I hope you guys enjoy learning too. I try to make this a somewhat entertaining channel, but most of all, I really hope that If you don't learn anything from me, I hope you learn something from the videos that we watch together. Obviously, not everything of what I do is going to be entertainment and education, but these guys over at Kurzgesagt make it really easy. They have great content. Go over to their channel and check it out. Support them over there. Subscribe to their channel. Do all that good stuff. And in the meantime, if you enjoyed this reaction, go ahead and hit that like button. Consider hitting that subscribe button to help this channel out. And as always, guys, leave more suggestions down below. Is there any more entertaining educational videos that we should check out? You know, what's out there? What do you want me to check out? Maybe there's something out there that I don't know yet and you want me to see a video on something. Maybe it's historical or science related. We can check those out. Just leave it down in the comments below and we can get to it. As always, guys, thank you so much for watching the video. Thanks for stopping by. Take care of yourselves and have a great day.